Hello, hello, hello. Welcome to CDCon 2020. I am so excited to be here. I hope everybody is having an amazing time, and I thank you so much for taking the time to attend my talk. Today I'm going to be talking about an introduction to Spinnaker on Kubernetes. For those that don't know me, I am the director of open source software at OpsMX. I am a Jenkins contributor. I am a SIG lead in many of the special interest groups within the Jenkins community. I'm a Google Summer of Code and a Google Summer of Docs org admin and mentor. I am a Kubernetes org member as well as the release manager associate, working with awesome people putting out the quarterly Kubernetes releases. I'm also a Spinnaker contributor. So what are we going to be talking about today? Well, we're going to be talking about Spinnaker on Kubernetes. I'm going to give you an overview of these two technologies. I'm going to build a local Kubernetes cluster and install Spinnaker in that cluster. I'm going to build a simple pipeline that do promotions through environments. Let's go ahead and start with the Kubernetes overview. Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitate both declarative configuration and automation. The name of Kubernetes originated from Greek, meaning helmsman or pilot, and Google open source Kubernetes project in 2014. A lot of times I get asked, what is Kubernetes? So I kind of took these high-level constructs of what I found were the very core tenets of Kubernetes. And those are service discovery and load balancing, storage orchestration, automated rollouts and rollbacks, automated bin packing, self-healing, as well as secrets and configuration management. Let's dive into that a little bit more. Service discovery and load balancing, when used with Kubernetes, can expose a container using DNS name or the own Kubernetes IP address. If traffic to that container is high, Kubernetes is able to load balance and distribute the network traffic so that the deployment is stable. Kubernetes allows you to automatically mount a storage system of your choice, such as local storage or public cloud providers and more when doing storage orchestration. You can describe the desired state of your deployed container using Kubernetes, and it can change the actual state to the desired state at a controlled rate. For example, you can automate Kubernetes to create a new container for your deployment, remove an existing container, and adopt all their resources to the new container when doing automated rollouts and rollbacks. You provide Kubernetes with a cluster of nodes, and it can use that to run containerized tasks. You essentially tell Kubernetes how much CPU and memory or RAM each container needs, and Kubernetes can fit containers into your nodes and make the best use of your resources when we think about automatic bin packaging. Kubernetes restarts containers that fails. It replaces containers or kills containers that don't respond to your defined health checks, and it doesn't advertise them to the client unless they're ready to serve. Finally, Kubernetes lets you store and manage sensitive information such as passwords, OAuth tokens, and SSH keys. You can deploy and update secrets and application configurations without rebuilding your container image and without exposing your secrets in your stack configuration. Kubernetes does a lot of great things, but there is some things that Kubernetes is not. Kubernetes does not deploy your source code and doesn't build your application. It doesn't provide application-level services such as middleware. For example, manages buses or data processing frameworks, for example, Spark, or databases like MySQL or caches, or non-cluster storage systems, for example, like Ceph. as built-in services. These type of components run on Kubernetes and can be accessed by your application running on Kubernetes through portable mechanisms such as open service brokers. Kubernetes does not dictate logging, monitoring, or alerting solutions. It provides some integration as proof of concept and mechanism to collect and export metrics. It also does not provide, nor does it mandate, a configuration language or system, for example, JSONet. It provides a declarative API that may be targeted by arbitrary forms of declarative specifications. And finally, it does not, nor does it adapt to any comprehensive machine configuration, maintenance management, or self-healing systems. What is Spinnaker? Well, Spinnaker is application management and application deployment. Those are its two core features. For application management, there's applications, clusters, and server groups. These are key concepts Spinnaker uses to describe services. Load balancers and firewalls describe how services are exposed to users. Then there's the application deployment. Things like pipelines and stages. There's deployment strategies such as blue-green and red-black, rolling blue-green or canary deployments. So let's talk about the setup of this demo. So I'm doing a few things here. One, I'm installing this with K3s, which is a Kubernetes distribution. I'm also installing Mini.io in K3s with a local volume. I'm deploying Halyard in a container within this Kubernetes cluster. And then I'm installing Spinnaker using Halyard. Let's verify the setup. I'm going to run a kubectl get namespaces, and here we can see that I've got my default namespace, I've got my newly created Ingress Nginx namespace, as well as my Spinnaker namespace, and all of my kube-related namespaces such as kubesystem, public, and node lease. Let's take a look over here, and if I run a kubectl get pods -- all namespaces, I can see that I've now got an ingress pod. I can have all my Halyard, my MariaDB, Mini.io, Cloud Driver, Deck, Echo, Front 50, Gate, Igor, etc., etc. So my cluster is now ready to be utilized. Let's verify that we can access the UI. Since this is a local development environment, I'm running at localhost. I'm going to go ahead and type that in, and as we can see here, I actually can get to the UI, so that's awesome. It means we're in business. So let's go ahead and look at our first pipeline. Some of the first things that we need to do is we're going to create namespaces within this cluster. Since it's a local dev environment, I'll be doing my promotions through namespaces. But if you have multiple clusters set up, such as, in various clouds or data centers, this will work with those clusters as well. But for this particular demo, I'm doing a local environment. So I'm going to set up a namespace of dev, test, and prod. And then I'm going to run a kubectl get namespaces, and we can see that those namespaces were in fact created. Let's create the application. So what you want to do in the UI is select Applications, and then at the top right you'll see Create Application. We're going to enter in a name, and we're going to go ahead and call this one Hello CDCon because we want to be original. Go ahead and enter in your email address and press Create. Now we're going to go ahead and create the load balancer. In the Applications tab, select the application we created called Hello CDCon. Now go ahead and select Load Balancers, and in the top right you'll see Create Load Balancer. Next, I'm going to enter in my YAML for a service and an ingress, and then I'm going to click complete, or excuse me, create. This is a little peek into the YAML that I actually created for this particular demo. I will open source these later on, along with the development environment that I used to build this out. So we're going to want to do the same thing for our test environment as well as our prod when creating new load balancers, just the same way we did previously for the dev environment. Go ahead and give it a try. Now we're going to go ahead and create a pipeline. So what you're going to want to do is in the UI, you're going to select the Applications tab. Make sure you're in your Hello CDCon application. You're going to select Pipelines and then select Configure a New Pipeline. We're going to go ahead and call this pipeline Deploy CDCon. We're going to add a parameter, and that'll have our tag in there. And then we're also going to add a stage along with the following YAML. So now we're going to start a manual execution. In the pipeline you just created, at the top right of the screen, you will see a button that says Start Manual Execution. Go ahead and click on that, and then we'll look through it a little bit deeper. And you can see that our deployment succeeded. Now, in this screen, you can actually click around and check a whole bunch of the various things, such as what were the various stages that happened, was there any manual judgments, to see how everything deployed and how long it actually took. There's a lot of rich data in here. And we can go ahead and launch our little Nginx page that we have, and we'll see that we actually did do a deployment. Congratulations. And see, the real beauty is this was just a very simplistic pipeline that we created, and it really is just the tip of the iceberg of all of the awesome things that come available to you out of the box for Spinnaker. And having that is just so powerful without having the overhead. And so let's take a little bit more look at what did we learn. So what are some of the other functionality that's available out of the box? You can do things like manual judgment, such as I can integrate Slack and say that a certain approval needs to come from a particular person in Slack. Or let's say I have a Jira ticket and a certain person in Jira has to approve it before the deployments can continue. You can have a manual judgment and a wait stage. I can say I want to wait 2 hours to make sure that my blue-green deployment's fully baked in and there's not a lot of trouble before I start allowing additional deployment. There's so much more that you can do with Spinnaker, and the amazing thing about it is this comes all out of the box. So what are some other things that we learned? Well, we know Jenkins can do CI/CD, but it can be difficult to do CD. We know Spinnaker offers a lot of the out-of-the-box flexibility. It also offers Kubernetes integration, and that's super powerful. It's not that we can't use Jenkins. You need a CI engine to be able to do CI, because if you recall in the beginning of the session, that Spinnaker is not a CI engine, nor does it do it. And it relies on other CI engines like Jenkins. So we still do need Jenkins, but we need a lot of flexibility on the CD part. And Spinnaker makes that super easy without having to use plugins or write extra scripts to handle our deployment mechanisms. I want to thank you, and I want to give some closing information. If you have any questions about Spinnaker or Jenkins or Kubernetes, you can definitely find me at the OpsMX booth if you'd like to know more. And also know that I'm an extremely approachable person on Twitter or LinkedIn or Spinnaker Slack or Kubernetes Slack. And when we are back in out of this world chaos and we are at in-person conferences, if you want to find me, please do approach me. You can email me at marky.r.jackson@gmail.com as well. I put my Twitter handle up here, as well as my LinkedIn, my GitHub, and on most every Slack you can find me at Marky Jackson. I really do like hearing from people, and I love to help as much as I can. I want to thank everybody for taking the time not only to attend CDCon 2020, but also to stop by and hear me ramble for a little bit. I really do enjoy the talking about technology, but I think even more so, I enjoy helping people learn technology. So if you have a desire to learn Kubernetes or Spinnaker or Jenkins, please don't ever hesitate to reach out to me. I love mentoring people and I love making people laugh. So I really want to thank you for giving me the time. Have a great rest of CDCon 2020 and enjoy the rest of the speakers. Thanks, everybody.